All right, your data has come back. In this video, I'm going to show you how to process it and put it together as an image in Afterglow, a Doppler image, where we're going to use color to visualize the motion, the rotation of Andromeda. Okay, first let's check out our preliminary data products. Click here. I like to go to the path map first. This looks very nice and clean, no problems there. In fact, I can see Andromeda in the first map. It's right here. Remember, Andromeda is about 4 degrees across. Our beam is less than a degree, so we can just barely resolve Andromeda. We're not going to see detail, but we will see its elongation, which is enough to study its rotation. We also see it in the other channel's preliminary plot. Now, the difference from before is we have another set of plots. Remember, in high-resolution mode, we're collecting 2 spectra. This is 15.625 megahertz across, so a much narrower spectral range, and in there you see the hydrogen emission line. This is a lower frequency spectrum. We don't see hydrogen in it, and we're not going to make use of that. The lower 2 maps were made from the lower high-resolution spectrum. The upper 2 maps were made from the higher high-resolution spectrum. Now here we can see the 21 centimeter H1 emission line, but that's not of Andromeda. That's of our own Milky Way galaxy. We have to look through our galaxy to see the Andromeda galaxy. And our galaxy is much closer, so the primary thing that we're seeing here is Milky Way hydrogen. What about the Andromeda hydrogen? Where's its emission line? Well, it's here, but it's been kind of averaged out because we're mapping and we're not on Andromeda all of the time. In fact, most of the time we're off Andromeda and not getting any 21 centimeter emission from it. So in a map, it gets averaged out. We don't see it here in the spectrum. Now, if you want to understand it better, let's do a little aside. I took a separate observation where I stared at Andromeda for about 5 minutes without mapping, just stared at the center of Andromeda, and then I moved off source and collected another 5 minutes of data for comparison. Here are the results of that. So here is the on spectrum, 5 minutes, not mapping around Andromeda, but just sitting straight on its center. Again, you see the Milky Way hydrogen, but now you can begin to see the Andromeda hydrogen. And it shifted because remember, Andromeda is moving towards us. So that light will be blue shifted. Its frequencies will be higher, and that's what we see. Here we see the frequency in megahertz. And so from this frequency, we can calculate how fast Andromeda is moving towards us. And we'll do that in a later video. Here is the off spectrum. Now we're off target and we don't see that. So it was visible in the on, it's not visible in the off. But when we do galaxies farther out, that signature will be even fainter and it will be hard to see compared to these oscillations. The oscillations in the spectrum are purely instrumental. We would like to subtract them out. And that's why we get both on and off spectra. We take the on, we subtract the off, and the instrumental oscillations disappear. A lot of the 21 centimeter line from the Milky Way will disappear because it's at about the same place in both the on and the off spectra. To flatten it, we divide by the off spectrum, getting an on minus off divided by off spectrum. And that's what we were looking at here. Gets rid of all those undulations and everything, makes it far easier to see the Andromeda emission line. And you also have some leftover imperfectly subtracted Milky Way 21 centimeter H1 emission line. Okay, so what we're going to do, we're going to go back to our Andromeda map, and we're going to turn it into images. We're going to turn it into 5 separate images. We're going to do something very similar to what we've been doing in the optical. We're going to make an LRGB plus narrowband image. Here's that same on minus off divided by off spectrum. For the luminance filter, we're going to integrate all the frequencies from right about here, just to the right of the Milky Way H1 line, to about here. So it will exclude the Milky Way emission, but capture all of the Andromeda emission. Now, this side of the line, the lower frequency side, corresponds to this side of Andromeda that's not moving towards us as quickly. That's the side that's rotating away. This portion right here corresponds to the emission from the middle. And this side of the galaxy, the higher frequency side, corresponds to the part of the galaxy that's moving towards us even faster because it's rotating towards us. That's this part of the galaxy. So the luminance band will encompass all of that, and then the red, green, and blue bands will encompass the lower third, the middle third, and the upper third of that range. Finally, just for fun, we're going to integrate over the Milky Way cold neutral hydrogen and use that as a narrowband filter, just like we used H alpha and S2 and O3 at optical wavelengths. We're going to use not H alpha, but H1 as a narrowband filter, and that will show us where the gas is distributed in our own galaxy. All right, let's do this. So let's come back to our observation here. You may want to give the job a name because your teammates may also be processing data on this page, and this way you know which jobs you processed versus the jobs they processed. Both channels look good, so I'm going to sum them. We want the high frequency spectrum. You want to use the defaults for everything else, at least for this first image. We're going to make a change here for the following images. If a lot of people are doing this simultaneously, you may want to uncheck include raw. That makes things go faster if you uncheck it. So our frequency range will start with the luminosity filter. You select luminosity and it automatically puts in that frequency range for you. We don't need any skip frequencies in this case. Background subtraction, we use 6 beam widths if we're looking at point sources. This is not a point source, it's extended. So I recommend making it a little bit bigger. Let's say 8 beam widths. It's not a bright target, so let's select faint target. And lastly, let's modify it. Instead of making a measurement quality image, we're not going to measure anything on this image. Let's make a display quality image. Okay. I'm going to hit let's go. You can see it's pending. And as long as no one else is hitting the server at this moment in time, it should only take about 10 seconds. You have to refresh the page to see when it's done. There we go. It's completed. And once it's completed, you want to download it. Okay. Now, that was the luminance layer. Let's create a new cartographer job. First thing we're going to do is change the time delay option to custom, and it has the value you just measured. This guarantees that all the other maps are corrected in exactly the same way that your luminance layer, your luminance map, your luminance image was corrected. You want them to all use the same correction because they'll then all be the same size and they will fit together much more easily when we group them in Afterglow. I'm going to change luminosity to red and submit. New image, keep it on custom, change red to green, submit, new, change to blue, submit, new, change to the Milky Way H1 line. That's our narrowband, submit. Let's see. This was our luminance layer. This is our red layer. Click on it to reload it, download. This is our green, click on it, download. This is our blue, download. And this is our narrowband Milky Way H1, download. Okay, now that we have them all downloaded, we can go to Afterglow. We're going to load in these files. I'm in my workspace. I'm going to upload these 5 that I just created. They're not huge files, so it doesn't take long. Search on them. I believe they are the ones I labeled DR, so here we go. Open. Let's check them. The first one was the luminance. Here we see it extended like we anticipated. Here's the red side of the galaxy. There it is. Here's the green part, the middle of the galaxy. Here's the blue side. And if we come down here, we can see the Milky Way H1 that we're looking through. It's scattered all over the place. Now, we're just clicking on the main map. It's the first layer in each group. The other layers tell us other things like the path map, and we don't need that right now. So go to the main for each one, right-click, and remove it from the file. I'm going to separate all the mains. And then take the ones you just separated. Click on them. Should be 5 of them. And group them. Make a new group. Here it is. And at first, it doesn't make any sense because we have to set everything. So luminance, red, green, blue. Let's take our narrowband. As we did with optical, we're going to put that above the luminance layer. Okay. And let's turn that one off for the time being. Here's the luminance layer. So we're going to color it gray and change its blend mode to luminosity. Here's the red, change its color to red. Here's the green, change its color to green. Here's the blue, change its color to blue. Let's look at the composite. And so we can begin to see what's going on here. Here's Andromeda, and we can see its red, green, blue rotation. But we can make this a lot better. Let's go to Display Settings, select the luminance layer. We're going to link them, and we're going to link them using percentile. We're not going to do pixel value. There are no stars here to calibrate against catalogs. So link using percentile. Okay. So now everything's linked to the luminance layer. Let's put it in midtone and hit default. Okay. We got to set the background and midtone levels. I'll go to the luminance layer. and increase the background. Let's try 10%, 20%, trying to get just below this peak here. You may have to zoom in. Yeah, maybe a little bit more. 30%. I'm going to back it down. You want to be a little bit below, so I'm going to back it down to 25. Okay, let's come back here. And you can change the midtone level. We do have some junk down here, and that's because this particular image, when I took it, the sun was pretty close. And so this is interference from the sun, sunlight, radio waves, bouncing off the support structure of the radio telescope, getting into the receiver. I'm going to increase my midtone level. Let's try 99. That tamped it down a lot, yet the galaxy is still nice and strong. Okay, pretty good. Now let's turn on the Milky Way H1 layer. I'm going to color it Bomber. Now, Bomber is the color for H alpha. This is not H alpha, this is H1, but you get the idea. So with this pink, you can color it something else if you want. But with this pink here, we are seeing the hydrogen gas that's nearby in our galaxy that we're looking through. Then far, far away, we see this. Now, I'm going to switch to that H1 layer. I'm going to unlink it. And I can adjust it. Let's see. Its background. I should probably go a little bit lower than 25 in this case. Let's try 20. Okay, that's good. And back to the full group. If I want to make it stronger, I can lower the midtone level, something like that. If I don't want it crossing the galaxy here, I can go from screen to lighten and see that kind of dimmed it a little bit and let the galaxy shine through more. That's really your call. I think I'll go back to screen. Okay. And that's my image. Be sure to save it. And if you want, you can export it as a JPEG. And yeah, it doesn't have the resolution of an optical image. Radio telescopes are blurry, but it's still pretty cool if you understand what the colors mean. In this case, the pink, that's the gas we're looking through in our own galaxy. And then we see this distant galaxy and we can see its rotation in color. If you look at Andromeda through an optical telescope, it's pretty, but you can't see its motion. Here we are actually seeing its motion. All right, I'll stop this video here.